Amici di Innovation Post, siamo allo stand di DFKI e SmartFactory KL con il professor Martin Ruskowski che ci spiegherà adesso le 3 aree applicative in cui queste istituzioni spiegano il futuro dell'automazione dal lato dell'infrastruttura, dell'intelligenza artificiale e dello smart safety. Professor, let's start with infrastructure.
Yeah, we see here the modular infrastructure of Smart Factory. We see a rack, and this rack is providing a standardized plug for all our modules. And the special thing that is all that is needed to provide the standardized infrastructure is in with this rack. So we have here power supply, we have TSN Ethernet, we have air measurement for the pressured air we use, and we have edge computing, which is a modular in the factor of the future, that we have a computing device which takes the registration of the modules I plug into our standardized plug here.
Okay, so this is the cabinet of the future, and it drives all the modular machine we see is behind you.
So because in the factory of the future, we have a high level of rearrangement of production modules, and we need a standardized way of connecting to the infrastructure. We cannot connect always power, air, and Ethernet separately. We need one standardized plug, and that concept we are showing here on our booth.
So what's doing this machine?
So our machine is producing business card holders in several steps. We see here the production step of a cover and of a laser engraving. We have the first step on the right side, where the base plate is produced. And the third line we see over there is doing the quality control in the end.
And in the middle we see 2 mobile robots.
In the middle we see 2 mobile robots which are connected via 5G. So our real-time TSN Ethernet is extended to 5G Ethernet, and the mobile robots are connecting the 3 production lines with another.
So the concept here is first of all to see how modular layouts in the factory are really feasible.
Right. So we are showing the concept of a modular production and of production islands consisting of these modules again, and how they are connected to the intralogistics and the transportation systems. And what's very special about our robots is that they are safely connected to our production lines. So we have always the issue when a robot connects to it physically, and I press the emergency stop, that the production line is not stopping as well. And it's very important that we get it into a closed safety circuit. And that we are showing here a concept. The robot goes to the production line and connects safely to the emergency stop circuitry.
And is this also, from a normative point of view, okay?
Yeah, so we are working together with TÜV Süd, the German safety organization, and we have developed a way to certify this modular safety according to the European machine regulations. So that is really a way to do it in the right and legal way.
Okay, so let's try to describe what's happening here.
Yeah. So the production works that we start an order on our first line. It's a base plate of our business card holder. And the special thing is that our business card holder has an RFID chip inside. We see one over here in the production line, and you see the black RFID chip over there. And the all of the production order is stored inside this chip. Yeah, and so the product routes its own way through production. We don't have a central MES installation, so all of the production is done decentralized. So like a car is driving through roads in a city, our product is driving its way through our production modules.
That's also the reason why we have an edge controller inside the cabinet.
Yeah, so we need the edge controller for this decentralized connections to our centralized server rack we have over there in the rear. Yeah. So we have the first 2 production steps in the first module. Then we have our base plate with a clip, and that then is transported. We can see it here more in detail. So first we have a base plate carrier, which is coming out. The second module is placing the base plate on the carrier and writing the production order within this base plate. The third module is then providing a clamp, which is pushed into the base plate. Then, via the docking station, the robot brings it to the second line, The second line is applying a cover and lasering a QR code on top, which is the business card file you can enter with your business card data. And when that is done, the third line is doing the quality check. We are controlling the weight of the part, and we have an optical control with a camera. And so we can sort out wrong parts. So that is the basic production flow we have here.
And we see artificial intelligence also.
Artificial intelligence is built into the modules. So we show real use cases of AI. One use case is, for example, that very often machines, you have defects and you can hear them. And experienced workers can hear if something is wrong. And we want to bring this capability to the module itself. So we have a microphone in the module, it's a module over there, where we can identify if a noise is occurring, which is uncommon. So we have an anomaly in the noise or in the sound and find out there's something wrong. And now we have a pre-classification in the module. We have a second classification level in the cloud, so it can send data also to the cloud. And if the sound is new and not known before, then the human is asked. And the human can identify it's a sound which is okay or it's a sound which is false.
Okay.
And from this input, the system can learn. The next time it knows, oh, I have heard this sound already, it's still okay. Or I've heard this sound, no, that's wrong. Something is broken within my module. And so the module can do a first assessment of its situation and can call the serviceman in the right way. And the serviceman can bring already the right tools and replacement parts in the future. And that what we are showing here with just a microphone, you can use, of course, with more sophisticated sensing. So with vibration sensing, with cameras, with optics, with any kind of sensor data you have, you can use this principle. A second use case we are showing is with a camera. So we have cameras in all our modules that are small white cameras. I don't know which this one over here.
Place someone.
Here,
Okay,
we have one here, right? And these cameras are monitoring the production line. They are transferring their data over the TSN Ethernet, the real-time Ethernet. So we are showing the real-time data in conjunction with non-real-time video data, that it really works. And we can use this data to identify products and to check the quality of the products during the production process. So future production must make sure in the modules that every module is producing 100% quality. And so you need quality control everywhere. And AI is able to help me with this quality control everywhere because I just apply a sensor, for example, the camera, and just do a classification of each part and say later on it's okay or not okay. And the module is learning which parts are okay and which are not okay and can sort out the wrong parts during the production process.
Okay, so the artificial intelligence allows the user to have more a knowledge of where a process is okay or not, but the final decision on whether to take for good the product or not is the operator or the system?
It's always the operator.
Okay.
The system only makes a suggestion.
Suggestion. Okay.
Yeah. Artificial intelligence can only make analogies. So it can say it looks like this one. It looks like that one. With a probability of 80%. Yeah. So it can sort out products which are problematic and just gives them to the human. And the human says no, it's still okay, and the system gets better. But it's always the human in the end who's making the decision. It's very important to realize artificial intelligence is not intelligent. Artificial intelligence is additional sensing for us. Yeah, so it's helping us to cope with data, with camera data, with microphone data, and help us.
Let's say something about SmartFactory KL. It is a consortium of how many enterprises?
Yeah, so SmartFactory KL is an association, in German a Verein, of 52 members, which are companies, which are research organizations, which are software companies, consulting agency, and so it's a very, very diverse mixture of members. And it's a platform where everybody can work together on this, topics of Industry
Future
4.0
application.
and artificial intelligence in production.
So the enterprise, the companies, they give you the existing products and
No,
you...
they don't give us products. They come with their staff to us and bring their products with them.
Okay.
And they are building.
And you
something.
together build an application.
We together build it. So we are living from the engagement of our members. So what you get at SmartFactory Kaiserslautern is really the platform that you can work together with somebody else.